Hello, kids. I'm back with another unique topic, which is not actually discussed by the Cambridge Physics book. Perhaps it is taught by other courses or other supplement courses for Cambridge Physics, but it's not available in either in the content, subject content of Physics 0625, neither it's available in the book. It's called Scientific Notation and Significant Figures, and most of the time kids are not able to write the numbers for physics accurately, and they lose marks over there. So I'm just going to go through this topic. I think it's a very critical topic. So let's get into this. So what is scientific notation, right? So scientific notation, as it suggests, it's a way to write numbers in a scientific manner. So let's say if I have a number, a value for you can say uh, a very small amount of distance, let's say 0.00026 centimeters, right? So if I'm supposed to be writing my answer in centimeters, if I'm supposed to write the answer in centimeters, I need to understand that these are too many zeros, right? So what is scientific notation? It is a method to write numbers in a way that the first digit uh, must be, and that's the key rule, must be non-zero, right? Uh, and then I'm going to relate this to significant figures as well, because that's what IGCSE physics examinations want. They want you to write at least three significant figures for each numerical answer that you would be giving. So for scientific notation, if I want to write this number uh, in a scientific manner, I need to understand that my first digit before the decimal must be 0 before decimal, right? So I can write this number as 2.6, but what about the zeros now? Now we do know that we can move this decimal 1, 2, 3, and 4 places here and convert it into a power of 10. And in this case, and remember, if we let's say if the decimal needs to go this way, then it's 10 to the power negative, right? And if we actually want to go the other way around, let's say if a number has too many zeros, let's say 6,000, uh, here's the decimal. If I want to go the other way, like this, that it is going to be 10 to the power positive, right? So keep that in mind. To the left it's positive, to the right if you move the decimal it is going to be negative. So in our case it is moving 1, 2, 3, 4 decimal places. So I'm going to write 10 to the power minus 4 centimeter. Now I've rewritten this number in a scientific manner, and this is acceptable globally, while this number may not be acceptable by any scientific organization or any scientific document. This is going to be considered as invalid or a wrong method of writing the number. As I said, we can use scientific notation for very large numbers. Let's say if we discuss uh, let's say uh, the diameter of Earth, which is actually 128. Now it is going to have several zeros at the back, right? So it is actually the radius is 6.4, 6400 kilometers. So that is going to be 1, 2, 3, 4, and 5. So that's a lot many zeros. I don't want to write that, so I'm just going to write 1.2 into 10 raised to power uh, 12 meters, or 1.28 into 10 raised to power uh, 9 kilometers, right? So I'm just going to remove this decimal from here, right? Okay, that was wrong. Okay, so this is what you need to do when you're writing numbers. This is what you call as scientific notation, that numbers should be written in a proper manner so that they can be understood and read readily everywhere where they're needed. Now I'm not sure whether I've written these zeros correctly, because for 12 I need to go for a lot more zeros. Let's just say 1 12, right? So it's going to be 1 2 3 4, 5, 6, 7, 8, 9, 10, 11, and 12. So yeah, so that's the number we're supposed to be working with in terms of meters. So again, that would be too hard for anyone to understand because there are too many zeros to read out. So obviously this is giving you a better idea of what the number is, right? So let's do some practice before we move on to the next topic. uh, let's say we have a number 0.000613, and we want to convert it into scientific notation, so it would be again 1 2 3 4, right? So I'm moving to the right, so the power is going to be negative, so 6.13. Now over here this is a non-zero digit. Remember, you cannot use 0.13 in any case, or 0.16. Never write the 0 before the decimal because that's considered wrong. It's not a scientific number. So we're going to represent it in the power of 10, and since we have moved 4 decimal places, so that's the number. Let's write another big number, 643, couple of zeros, right? And obviously when we don't have the decimal, we can say that the decimal is at the end, so we need to go 1 2 3 4 5 6 and 7, right? 7 places, and we're going to the left now, so it is going to be 6.43 into 10 raised to power plus 7, right? Let's write some more numbers. Let's write a number that already has a power to the 10, right? Let's say someone wrote this answer 0.100136 into 10 raised to power 5, right? It's a positive power. So again, it is going to 1 2 3, 3 places here, so I'm going to write 1.36 into 10 raised to power again we're moving to the right, so it's going to be minus 3, and we already have this 10 to the power 10, so we're going to write 10 to the power plus 5, right? But I need to resolve these, since in mathematics we say that if ax to the power a multiplied by x to the power b, then we say that it is x a plus b, right? The powers add up. The same is this case, so we're going to rewrite this number again, 1.36 into 10 raised to the power 5 minus 3. So this can be a negative number or positive depending what the sum of these powers are going to be. So the final number is 1.36 into 10 raised to the power 2, right? So it doesn't matter if you have already 10 to the power somewhere and you're having this kind of a number. Just write that independent power alone, just like this over here, and then add up this original power, whether it's positive or negative. So let's do another practice number. Let's say it is 643.02 into 10 raised to power minus 6, right? Now again, this is the decimal is supposed to be after the first digit, so we're just going to move it 2 places here, so it is going to be 6.43 into 10 raised to power. Now we're moving to the left, so it is going to be plus 2 into 10 raised to power minus 6, and since the bases are same, the final sum is going to be, now I'm not going to do this this step over here, this one. I'm just going to write the final answer. It is going to be minus 4, because 2 minus 6 is going to be minus 4. Let's go for another number. This time around I'm going to have 64300.6, right? Now again, I missed this. Why? Because I just said that Cambridge wants you to write 3 significant figures, so this 02 cannot be rounded off, so I just omitted in my answer. This is a 3 significant number answer, so it would be accurate and it would be considered by Cambridge as a correct answer. So I'm just going to skip this 02. The same is going to be a case over here, and why I'm skipping this, we're going to look into this significant figures, and we're going to look into these rules over here, right? So we're going to get into that in a moment. First let's convert this. So let's put a power 10 to the power 4, so I'm just going to go again 1 2 3 4 decimal places, so it's 6.43. again I'm not going to use this 006 because that will again make my number very large. I'm just going to write we moved 1 2 3 4 4 positive places into 10 to the power 4 again, so that is going to be 6.43 into 10 to the power 8, right? So this is how you write scientific numbers, or also known as scientific notation, right? Now we're going to get into another topic linked with this, which is significant figures, right? Okay, what are significant figures and how do we write them? We need to go through some of these rules. So first rule is all non-zero numbers are significant. That means you must consider them while writing your answers. Zeros between two non-zero digits are also significant. We need to understand that. Leading zeros are not significant, which over here, even in the scientific, we discussed that this is a leading zero, and we did not consider this for scientific notation. So that's also the case for significant figures. Then trailing zeros to the right of the decimal are significant. These are trailing zeros right over here. So as an example, so these are considered significant. Why we consider as these as significant, I'll discuss in a moment. And trailing zeros in a whole number with decimal shown are significant, right? Right, okay. Now, the first rule, we're going to see all non-zero figures are uh, significant. So if I write a number 465 kilometers, right? So all three of them are significant. How many significant figures are there? There are three significant figures over here. Now, if I write this number 0625 kilometers, then again I have only three significant figures. I don't have four. Why? Because the this zero in the start is not considered as a significant figure, right? Again, if I write 0.265, this zero again is not significant, so I've again got three significant figures in this number. Why? Because again, this is first of all not scientifically written. Once I convert this into scientific notation, it is going to be 2.65 into 10 to the power minus 1. So again, you can see these are three significant figures over here. We can rewrite this number as 625. This already is written correctly. So again, three significant figures. So that's our rule number one, right? All non-zero digits are considered significant. Over here, our 6 was also significant, but we omitted this because our significant figure requirement is just for the 3 digits and not more. Some, once you go into your advanced studies, let's say for graduation or for masters or PhD whatsoever, you will be coming across very large numbers, and most of the time you will be required to write significant figures up to 6 digits, right? So your answer should be accurate up to 6. In that case, I won't be able to omit this 6, which I did in my case over here, right? As I said, at your level, only 3 significant figures are considered. I suggest students for IGCSE to go for 4, but 3 is fine if you can write those 3. Okay, zeros between two non-zero digits are significant. Okay, now sorry, let's say if you have a number, it says 6205 kilometer, then the zero between these two significant numbers is also significant, right? So for over here I've got 4 significant figures, right? I cannot omit the 0 because it is in between these two values. Similar is the case for a decimal, right? So if I have 6.024, even this 0 is significant, so I will write I've got 4 significant figures over here. So again, this number can be rewritten like this. As I said, it's already correct, so I'm not going to change the number, whatever the units are. Now, it's a very easy rule to follow. Leading zeros are not significant. What are leading zeros? I just gave you an example. This is a leading zero, right? So I'm just going to note another example. Let's say 0.00625 kilometers. So these are leading zeros and they are not significant. So I have only 3 significant figures. Even though I've written 6 digits over here, so I will rewrite this number correctly as 625 kilometers, right? Finally, Moving on to the next, I think this one is a very easy rule to understand. Trailing zeros to the right of the decimal are significant. Now this is a very important point. Let's say if I have 6.20 into 10 raised to the power 4, right? So this 0 is significant. You cannot omit this. Over here I've got three significant figures because trailing 0 to the right, and it's a trailing 0 after the decimal, so it is actually significant. So I will consider this as 6.20 into 10 raised to the power 4, or 6 to and then I'm going to move 0 and 0 0. So even these trailing zeros, when I remove this 10 to the power 4 into these zeros, translate this without the power, these are also significant. And in this case I had three significant figures, and now in this case I actually have five significant figures, right? So keep this in mind, that these zeros are not useless after the decimal, especially when they're trailing after the decimal, especially when there's a 10 to the power. So remember that these zeros you cannot omit. You cannot write this as 6.2 into 10 to the power 4. It would be considered wrong by the examiner because you omitted a significant figure over here, which was the 0, right? So do not omit this. It would be considered wrong. Okay, final rule: trailing zeros in a whole number with the decimal are shown are significant, right? If you get an answer something like this, let's say I calculated an answer and it's a whole number, let's say 8 centimeter. As I said, you need to write three significant figures, so you must add these two zeros, and these two will be significant. If you simply write your answer as 8 centimeter, I think I'm not going to consider this as accurate. I think Cambridge also enforces this rule that you need to write three significant figures nonetheless. So I'm just going to add these two zeros, even though it's a whole number, and since it's a whole number, I can easily write these zeros without having any error in my reading, and that would be right. And now I have three significant figures over here, while I wrote this as one significant figure, and that would be incorrect, right? So these zeros, extra zeros that are there, they actually represent precision. If you remember, I discussed precision in unit 1 of the measurement, that what is precision. It is the closeness to the between the values, and we can only relate closeness or the least count by these zeros. So these zeros actually represent how smaller a reading can be taken by an instrument. Let's say if I'm taking this reading using a vernier caliper, then I must write these zeros because a vernier caliper can actually read to these zeros. If I just write 8, if it's a fixed object with 8 centimeter of length, it doesn't mean that the vernier caliper cannot read these zeros. It can, so it must be written as 2 of these zeros. I know it's a bit of a confusing concept, but understand that if you have a whole number answer like 6, you must put a decimal, put two zeros, and then write your unit, and that would give you three significant figures required by Cambridge, and that is fully acceptable. No one is going to make this wrong, that you wrote these two extra zeros. You actually must write this to ensure that you're dealing with high precision, right? So I hope we're clear with this topic. If any ambiguity is still there, just post a question and I'll try to respond to those questions as soon as possible. Thank you for your time. Bye bye.